Hello everyone, welcome once again to our lecture about Newton's method. So we'll use Newton's method in optimization. So the objective of our lecture for today is uh, to be able to use Newton's method to find the maximum of a function. So this is another application of Newton's method class. Okay, so the root equation and optimization are related in the sense that both involve gazing and searching for a point on a function. Root location involves searching for zeros of a function, while optimization involves searching for either the minimum or the maximum. So the optimum is the point where the curve is flat. This corresponds to the x value where the derivative f prime of x is equal to 0. Additionally, the second derivative f double prime of x indicates whether the optimum is a maximum or a minimum. If the second derivative of the function of x is less than 0, meaning negative, the point is a maximum. Otherwise, if the second derivative of the function of x is greater than 0, meaning positive, then the point is a minimum. So Newton's method. The Newton-Raphson method is an open method that finds the root of a function using this formula. x sub i, x sub I plus 1 equal to x sub I minus f sub x sub I divided by f prime of x sub I. Okay, so the value for this x sub I plus 1 is simply the initial value that is guessed at the start minus the value of the function at this value of x sub I divided by the value of the first derivative at this value of x sub I. A similar open approach can be used to find the optimum of f of x by defining a new function. Our new function now is f prime of x. So it's still a function. The first derivative is still a function of x, leading to the equation x sub I plus 1 equal to x sub I minus f prime of x sub I divided by f double prime of x sub I. So this is our first derivative. This is our second derivative. So this is used to find the optimum. No? Similar approach can be used to find the optimum of f of x by defining a new function. So this is our new function class, leading to the equation, this equation that involves the first and the second derivative. So to find the minimum or maximum of the function of x. For example, if you are given this uh, equation or function of x 2 sine of x minus x squared over 10, then we will use the Newton's method to approximate the maximum of this function. So our solution, so with the initial guess of 2.5, so we'll use guess because we have only one guess here, 2.5. Okay, so for our solution, so first we need to find our first derivative and then the second derivative. So the first derivative from this function is 2 cosine x minus x over 5. So I hope you don't have any trouble of having this one class because we've learned already the derivative of the trigonometric functions. Okay, then the second derivative. So second derivative is taken from this. So taking derivative this first derivative. So we have the second derivative, and this is negative 2 sine x minus 1 over 5. All right. So substitute the derivatives to the equation. So from this equation, So from this equation, you substitute the derivatives, the first and the second derivative, then we'll have this result. Okay, so this is our result. Then substitute the initial g's. This is the first derivative class. Okay, if you look at the previous slide, so this is our first derivative. Okay, this is our second derivative. Then substitute the equation. So our equation now becomes x sub I plus 1 equal to x sub I minus 2 cosine x sub I minus x sub I. So this is x sub I over 5 divided by 2 sine x sub I minus 1 over 5. Then substitute the initial gauge. Our initial gauge was that was 2.5. Okay, so this is our initial gauge. This is our x sub I, this one. So substituting it to the equation. So this is 2.5. 2 times cosine of 2 point, of 0.5. Oh, sorry, 2.5 minus 2.5 over 5 divided by 2 times sine of 2.5 minus 1 over x. Okay, so we use this initial gauge of 2.5. Okay, so substituting, we get this x sub I. This is x sub 1, no? X sub 1 because our x sub y, this is our initial value. This x sub I meaning the initial value. So the initial value, so this is our initial value. So this will be 0. Initially I is equal to 0. So this will be 0. So 0 plus 1. So we have x sub 1. All right. So this is our x sub 1. This is our x sub 0. So here our x sub 0 is 2.5. So if this is if I is equal to 0, so this will be x sub 0. This will be 0 plus 1. So 0 plus 1 is 1. So that's why you have x sub 1 here. Then we have the value of the function. This is our f of x 1.5. Now when you substitute the value of initial value x sub I, which is x sub 0 2.5, so you get the function f of x equal to 1.5. Okay, and then the process can be repeated with the following result. So I will not show you the solution class. You can practice now how to do that. So when you solve for x sub 2, your x sub 2 here meaning when I is equal to 1, so you have I equal to 1, so this becomes x sub 1, right? So I equal to 1, so this be 1, this will be 1 plus 1, so this becomes x sub 2. So you have the x sub 2, the next process, x sub 2. Okay, so when this is x sub 2, substitute the value of uh, sorry, when I is equal to 1, so this is 1 plus 1 x sub 2. So your x sub 2 will be x sub 1, this will be x sub 1. All right, so 2 cosine x sub 1 minus x sub 1 over 5. All right, and substituting, so you will get this. And when I is equal to 2, so when I equal to 2, so this becomes x sub 2, and this will be 2 plus 1, so x sub 3, so this will be your x sub 3. So your x sub 3 is equal to x sub 2, then minus 2 cosine of x sub 2 minus x sub 2 over 5 divided by 2 times sine of x sub 2 minus 1 over 5. Okay, then substituting. Okay, so you just do or repeat the process and you will get x sub 3 and x sub 4 and so on. And then you look at the result. So this is already stabilized. You see here. Uh, um, 1, 2, 3, 4, 5. So there are 5 decimal places that they are the same. So the error here is very less already. So you can take this value. You can step up to this part. Okay, so that's how simple this method, Newton's method, in finding the maximum or minimum. So to test whether it's maximum or minimum, we just use the concept here as mentioned at the beginning. Uh, Here. So if so, you have to determine that if the second derivative is negative, then the point is maximum. If greater than zero or positive, so the point is minimum. All right, so it means that from a result, this is just the value of x class, but we need to find the point. Okay, so meaning this is the point is composed of two values, the x value and also the abscissa and the ordinate. So this is the abscissa and this is the ordinate. No, x are the abscissas and these are the ordinates. So you can use this or you can use this one. Okay, so this will be the point composed of one point. Then to find whether that point is maximum or minimum, so you have to determine the value of the second derivative. Okay, so that's all for this part. And for your practice, try to solve this problem. Let's find the extrema of the following. Extrema means the maximum or minimum point. Okay, using Newton's method. All right, so I hope you will be able to solve this one. Just follow the procedure as shown in the previous slides. Thank you very much. Hope to see you again in our next video. Bye.